Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. In today's lecture, we'll be solving an interesting problem on stack. So this problem is called sideline, use sideline. So assume there are n tracks, number from 1 to n. Okay, number from 1 to 10. Let's say 1, 2, here you can see 3, 4, 5. Like, so this number is random. Okay, the trucks are coming on the road in random manner. And there is a side lane. So assume this is the side lane, this is the side lane, this is main lane, and this is side lane. Okay, which can be used to order the sequence of the truck properly. So what you have to do? You have to we have to so currently the order is random, right? But what we have to do? We have to make the order place them in correct order, right? 1, 2, then 3, then 4, then 5, right? This is our task using this sideline, one sideline, this sideline. Okay, so you have to say this is possible for this or random order or not. For this particular order, this is possible or not. This is the problem, right? There are trucks, in number of trucks, then you have to arrange them from 1 to n. Now let's see this example. Okay, what is the first truck? This is 5, right? But here what is the expected output? We want the first truck, right? We want the first truck, so expected output is 1, right? So first what we'll do, we'll go for this truck. Okay, what is the expected output? Expected truck is 1. So what we'll do, we'll side lane this truck, right? We'll place this in this lane. Okay, then what is the next truck? This is 4, but our expected truck is 1. Then what we'll do, we'll side this. Okay, we'll place this inside. Okay, then what is the next truck? Truck number 3. Then what is the expected output? It is 1, right? So we'll place this in this side lane. Okay, then what is this truck? This is truck number 1, right? So we'll just place here. Okay, now one truck is placed. Now what is the next truck number we are expecting? The next truck number is 2. Okay, then what will do? Okay, we go for this truck, we go for this truck. Okay, then we take this truck and arrange here, right? So now this is done, this is done, 2 is done. Then what we'll do, we'll go for truck number 3, we'll find truck number 3. Now this lane is empty, then we'll check for this side lane. So we'll take this, truck. I will take this truck and place it here. Okay, then expected output will be 4. Then we'll be take this 4, place it here. Then we'll be take this 5 and place it here. So now tell me, is it possible to arrange in that order? Yes, right? So for this output here will be true. Okay, let's see next example. Let's say the trucks are arranged in this order. Okay, now let's try for this. Okay, first what is the expected truck number? 1, right? So we'll take this, we'll pass this truck here. Okay, then what is this expected output? Expected truck number? So expected truck number is 2, but currently it is 3, so we'll place in the side lane. Okay, then we'll take this 5, but what is the expected truck number? 2, right? Then we'll place this in the side lane. Then we'll take this truck. What is the expected truck number? 2, right? Then what we'll do, we'll place it, arrange it. Then we'll take this truck number. What is the expected output now? Expected is 3, right? So we can't arrange them, right? Then we'll check for here in the side lane. In the side lane, is 3 there? Yes, 3 there, but we can't place this because 5 is top of the stack, right? So we can't remove this truck currently. So that means we cannot rearrange this thing. This will return false. 3 is there, but we can't remove this 3. We can't remove this truck number 3, right? That's why the result here will be false. Now let's take this example. Okay, first we'll take this truck number. Okay, 1. So we'll place here. Okay, done. Then second truck number 2, I'll place there. Truck number 3 there. Okay, truck number 5. So what is the expected truck number? Truck number 4. So then we'll place it here in the side lane. Okay, then we'll place this truck number 4. Yes, 4. Then what is the expected truck number? Truck number 5. So here it is empty. Then we'll check for the stack, right? Check for the side lane. So we'll take this truck and place it here, right? Now you can see this is possible, right? So here it will be returning, so the output here will be true. So I hope now you have understood the problem. Now how to solve this problem, how to check? To do this, we'll use stack, we'll use stack. So let's take this example, let's take this example, okay? The first example. So what was the order? Let's take a random thing. Let's take, let's say 5, then 4, okay, then 3, then let's say 1 and 2. Okay, these are the track number. This is the first track, this is the last track. Okay, so we have to rearrange them. Now take the first track. Okay, 5. Now is this the expected track number? No, right? Then what we'll do? We'll put this 5 here in the stack. Okay, then what is our element? Element is 4. But what is our expected track number? Track number 1. But currently it is 4, so we'll place 4 here. Sorry, 4 here. Okay, so this is done. Then the next truck number 3. So but our expected truck number is 1. Then we'll take this 3, put in the stack. Okay, then what is our next truck number 1. So what is our expected truck number? Truck number 1. Then we'll take this 1 and place it here. Okay, the truck 1 is placed. Then we'll take this second truck number. Okay, second truck number 2. Okay, then so expected truck number has changed to 2. Now we'll place 2 here. Okay, we'll place 2 here. Now the expected truck number is 3. Now but the array is empty. Then what we'll do? We'll check in the stack. Is 3 in the top? Yes. So we'll pop this thing and place it here. Okay, now what is the expected track number? Expected track number is 4. Now this is empty, then we'll check in the stack. So is 4 in the peak? Yes, it is in the peak. So we'll place here, and the next track number would be 5. So initial it was clear. So what is our expected track number? 5, right? Then we'll place 5 here. Sorry, pop 5 from here and then put here. So here you can see the tracker arrays from 1 to n. That's why the result will be true, right? Now how to do this? How to write the code for this? What we'll do? First there will be two things, right? One is main lane, one is main lane. Okay, one is main lane. This is main. This is side lane. So here the side lane actually behaves like a stack. Stack. When you place a track, let's say 3, but you want to remove this track, you can't do this because in the top you have to remove the 5 first, then only you can remove the 3. That means we can only access the last track, right? That is the basic example of typical example of stack problem. So to do that, first what you have to do? First we go through each track number, right? Each track number. That means we have to run a for loop for each element, right? In the tracks, right? In tracks. Okay, we have to go through each number, then track. Then what we'll do? We'll first maintain a stack. Okay, then what we'll check? First we check for the current element. Is this current element is our expected output? So we'll take another thing, expected track number, right? And initialize with 0. Sorry, 1. Okay, initialize with 1. So first we'll go to this element and we'll check, is this the expected track number? No, right? Is this the expected track number? No, right? Then what we'll do? We'll put this thing in this tag, right? So what we'll do? We'll put this st dot append the element. That will do if we don't find, right? Otherwise, let's say I find, so here let's say initially it was like 4, then 3, then 2. Okay, but our expected output is 1. Now let's say here I have found one. So what I'll do, I'll place this one here, place this one here, place this one here. Okay. Then what will be our expected output? 2, right? Expected output is 2. Now, before going to the next element, what we'll do, we'll once check in the stack. Before moving to the next element, first we'll check in the stack. So in the stack, is there any predicted output? Is there the expected track number available? If it is available, then we'll remove the item from the stack. Understand first. Let's say initially it was 4 and 3. Okay. Now it is 2 here. And here let's say 1 and 5. Okay. Now what is the expected output? So let's say expected output is 1. Okay. Now what we'll do? But current element is 2. So we'll put this 2 here. Okay. Then the current element is be 1, right? So what we'll do, well, whenever we find the current element is our expected element, will we pass this thing, will we pass this truck here, right? So 1 is placed here. Then expected output will be 2, right? 2, right? Now before going to this element, before going to the next element, once we'll check in the stack, in the side lane, is there this expected track number available? So here you can see the expected track number is exactly equal to the peak element, right? Then what we'll do, we'll just shift this track from here to here, right? Then what is the expected track number? Track number is 3. Then also we'll not go to this element, we'll again check in the stack. We're not going to the next element, we're again checking here. So when we find, so is the peak element 3? Yes, 3. Then we'll place this truck number 3 here. Then what is the expected truck number? 4, right? Expected truck number 4. Then again we'll check here. So is 4 available here? Yes. So what we'll do? We'll pop this 4 from here and place it here. 4. Right. Then when the stack is empty or we couldn't find the element, then only we can move to the next element. Now to solve this, what we'll do, one simple thing we'll apply. Let's say previously the stack was like this. Okay, 2, 3, 4. Okay, this was our output 1 and 5. Right, this was our problem. Now expected output is 1, right? So first what we are doing, we are checking in the element itself, checking for the current element itself. So rather checking in the current element, what we can do, this step we can avoid. What we can do, whenever we find current element, just append this, just push this in the side lane. Then what will happen? Our problem will be easy. So let's say 1 is here. Whenever we find a current element, we'll be pushing here. Okay, 1 is pushed. Then continuously we are checking in the stack. Is our expected output is equals to this or not? So what we are changing? We are, whenever we find a current element, we'll be pushing in the stack. Okay. Then we'll be continuously checking for the peak element until when we are finding the expected output. That is what we are doing, right? Now let's go to our VS Code and try to solve this. Okay, first write the problem for this. So what is the first step? Whenever find any element, will be stack dot append this element. Okay, this is our first step. Then what we'll do, we'll check while stack is not empty. So stack, and what we'll check, if this top element, whatever in the stack, equals to let's say expected track number. Okay, expected track number. Until then what we'll do, we'll pop this thing, we'll do st.pop. First step, what is doing, we are, whenever we find a new element, we'll be pushing in the stack. Then until the top element is equals to the expected number, until then we'll be doing this operation, we'll be removing the item from this side lane, right, from this stack. Okay, then what we'll do, So when we pop the item, we'll increment the expected track number. That means when we pop, that means we have found our expected track number, then just increment our track number. That's what we are doing. So expected number plus equals to 1. Right? Initially it was 1. When we find element that we pop from the side lane, then we just expect incrementing this expected out number by 1. Then at last what we'll have to do, we'll be checking if this tag is empty or not. If this side lane is empty, if this side lane is empty, that means we have successfully arranged. If this side lane is not empty, if the side lane has some track, right, that means we can't arrange the track. So this is how we can solve this. Right? So now let's go to our VS Code. Let's take an array. Let's say trucks. Okay, and let's say put like 5, then 4, then 1, 2, then 3. Okay, now let's create a function. So if use side lane. Okay, then it will take array trucks. First what I'll do, we'll take a stack variable, right? So take a space stack st equals to empty list. Then we'll take a variable, so expected truck number. Okay. Okay, let's initialize with 1 because our expected truck number for first expected truck number is 1. Now let's try to run a for loop, and loop will be going through each element. So for element in trucks, in trucks, what we'll do, first we'll push this element in the stack. So st dot append really. Okay, then what we'll do, while stack is not empty, and stack the peak element st dot minus 1 equals to our expected truck number. Until till then what we'll do, we'll just pop this item. Okay, pop this from the stack, and we'll increment the expected truck number. Expected truck number plus equals to 1. Okay, then at last what we'll do, we'll check if the stack is not empty. So that means return stack is not empty. Okay, this is the whole function. If the stack is empty, then we'll be returning true, otherwise it will be return false. So let's call this function. So uh, print this use side lane, then put this truck here. Truck. Okay, now for this one, what will be the first element? First element is 5, right? But our expected is 1, so we'll pass this, put this in the side lane. Okay, then what is the next element? Next element is 4, so our expected is 1, so we'll put this in the side lane. Okay, then 1, so 1 is our expected output, right? Expected truck number. Then we'll do nothing, then we'll just increment our expected truck number. It will be 2. Then what is the next element? Next element is 2, right? So 2 will also be going to expected truck number, then it will be 3 will be going to expected truck number, then in the stack it will be 4 will be removed, then expected truck number is 5 will be removed. That means the output here will be true, right? Let's run this. So here you can see true. Now let's put it as 5, then it is 4. That means in the stack first there will be 4, then 5, but our expected output will be 4, right? Then it will be returning false, right? Let's check. Let's try to run this. Let's clear this out first. Clear this and try to run this. So here you can see this is giving false. Now I hope you have understood the problem. This is very interesting problem. This is a typical problem on stack. So that's it for today. See you in the next lecture. Thank you.